Welcome to I Can Science That. Here's a video I've wanted to make for a very long time. I just haven't found the time. But today it came up in the chat and that just motivated me to make the time to make this video and finally talk about this topic, which is why can I see the stars all year round? Question from Onda Galapago in the chat. Someone who's interested in I think a little bit of the details of the explanation. The explanation so far have been too cursory. Let's get specific about why can I see the same stars all year round? In our heliocentric model, the idea is that the Earth goes around the sun once per year. And that means 6 months later, we should be facing 180 degrees in the opposite direction. So how could it be that if we're facing 180 degrees in the opposite direction, that we could see the same star at night 6 months later? Yes, it's confusing. It is interesting. So let's look at how that works. And as we look at it, I asked Onda to choose a specific location on the Earth and a specific constellation that we can talk about to evaluate exactly how it works with that constellation. Onda has chosen Ursa Major. Let's take a look. Ursa Major constellation. There's Ursa Major right there. And I have set my location to Barcelona. So that's what it looks like. And that's tonight, which is November the 3rd. November the 3rd, this evening, in Barcelona, you should see Ursa Major in the sky somewhere around about there. Okay, and to drill in even more specific, I wanted to focus on just one star. So let's take a look at what that star is. That is Alkaid, and I've looked up the information is up here. The right ascension and the declination are here. I've punched those into a simulation. Let's take a look and see if we can understand where the misunderstanding came from, and then can we visualize how it really works? Let's take a look here. Here we have your standard model of the solar system really here. The sun is the big ball in the middle. The green ball is the Earth. Obviously not to scale. If I made this to scale, they'd be too dinky. So we blow them way up so we can see what's happening there. Okay, and this blue disk represents the orbit that the Earth's going to go around. I can take you around that. Let's see here. Here's how we do an orbit. There you go. That's the Earth making an orbit around throughout the year. So let's put that back to where we started. This yellow line here is pointing to that star off in the distance. So it's pointing to a star. Let's then consider the question, can we see that star all year round? And in this diagram, I think we can agree that at this point, that star is in the nighttime side of the Earth, right? This is the daylit side, the green daylit, and the dark nighttime side. The star is in the night sky at this time of the year. But 6 months later, our nighttime view is now looking in the opposite direction, completely 180 degrees away from where that star is at. How can we see the star at this time? And we know that in Barcelona, we can. So how does that work? Well, let me explain how that works in just a few words. This diagram is a two-dimensional diagram, but the world is three-dimensional. So here's my three-dimensional simulation. Let's take a look at the same thing. I'm not going to change the dates at all. Let's just take a look at it from a more side-on view and see why can we see that at night. Boom. That's why. I don't know if it's obvious yet, but I think that's pretty dramatic to see the difference between when we're looking from the top, yeah, it's off to the left. But when we look at it from the side, we realize, yeah, okay, it's off to the left, but it's mostly straight up. And because it's mostly straight up, that is going to allow us to see that thing at night. Let's get in a little closer. I've made ourselves a little viewer. This is my viewer. This is you in Barcelona. Little you in Barcelona. This viewer I have actually placed at 40 degrees north latitude. A little hard to tell with no features on the Earth, so I just put an equator plane. Let's get rid of this one and keep this one. This is the plane of the Earth's equator. And so you can see, I think, that our little viewer is 40 degrees north of the equator. And I've made our little viewer looking towards the North Pole. He's looking northward, standing in Barcelona. Okay, so that's that. Let's lose the equator and just keep our viewer. And then the question is, well, he's in daytime right now, right? He's in daytime. Let's bring back the equator so we can see what happens very clearly during a day. He's in daytime. Let's see what happens throughout the day as he rotates. And then, oh, there's sunset. He's in the darkness now. It's nighttime. Now is midnight, and he's coming back up into the daytime. Okay, so right there at the dead of night, the deepest, darkest of night, that is our guy. And let's take a look. From this view, is that star above his horizon? It's clearly still on the on the opposite side of the sun, right? But the question is, it's nighttime there. So is that star above the horizon? It's a little hard to tell still from this diagram. So let's do this. I'm going to hide the equator and instead bring in a plane that represents the horizon of that viewer. That's your viewer's horizon right there. Everything above that plane is visible, and the star is above the plane. And in fact, the star is a little bit higher than I'm showing here. Like I said, it's not to scale, so that star should be even further away. Okay, and so that is why we can see that. Looking at that one more time from the top, let's do the same thing, but with Polaris this time. I have Polaris in the scene as well. And let's lose, shall we lose our other star for now? Let's lose our other star so we don't get confused. This is Polaris, and I want to show that because I think most people do understand that we can see Polaris all year round. And why is that? It is because Polaris is the star that we all rotate around. Polaris always stays in the exact same spot in the sky. All the other stars turn around it, right? They turn around it in a great honking circle. They go around Polaris because we're the ones rotating. So let's see how at nighttime here, it's clear that we're going to be able to see Polaris. It's way up there somewhere. Okay, what about 6 months later? Let's take a look at this when we move Earth around in its orbit to way over here. Well, our viewer is in the day side. So now we're going to have to wait some hours later before our viewer is now in the nighttime side. And there, Polaris is still clearly above the horizon. And the reason is because we orbit basically pointing that North Pole at the North Star. So the North Star stays in that same spot in the sky, and you can just visualize all the other stars going around it. We've all seen those time lapses. Any star that is within that distance, if that's Polaris right there, and that's the horizon, any star within that range will never leave your sky. It just goes around in a circle, right? And so Ursa Major is right here in that zone. And so Ursa Major does not dip below the horizon at all. By contrast, there are other famous constellations that do vary throughout the year. Orion is one that's very famous. Everyone knows how to recognize Orion, but it's not visible all year round. Only when that circle that it travels, right? It travels a circle like every other star, but it's a wider circle. So as Orion goes around, if it's up high in the daytime, you won't be able to see it. But if it's up high in the nighttime, 6 months later, you will be able to see it. And there's a contingent of folks out there who are convinced that this does not happen at all. The stars are always in the same spot all year round. Now, that's absolutely not the case. Let's go to Stellarium to look at that. Okay, here's Stellarium web version. So you don't need to download anything. You just go to Stellarium, just Google Stellarium online, click, and you're golden. And just run in a web browser. Okay, let's look at Ursa Major first. Ursa Major in Stellarium. I'm going to zoom out now. I'm getting a fisheye lens so you can see the whole night sky. Or at least a great deal of it. Right down here is where we can set the time. So I'm going to roll through the day. So here we go, rolling through the day, and we can see Ursa Major is going up high in the sky, and then at night it swings around and down in the sky. Okay, now, is that the same spot? Is that star in the same spot all year round? That's the topic. So here we are at November. There's December, January, February, March, April, May, June. Let's go to June. No, wait, May. May would be 6 months later, right? I don't know. It's later. Notice now it's daytime over there, and hey, wait, it's in the daytime. It's down in the sky. It's up high in the sky at nighttime. Let's see that again. Nope, wrong line. Back to November the 3rd tonight. Let's find the point when the bear is like horizontal, right? When the bear is just like horizontal, and it looks like it's right about at midnight at this point. Okay, so the bear is walking on the earth at midnight. And 6 months later, 1, 2, 3, 4, 5, 6 months later, what time is the bear walking on the earth? Let's check. First of all, the bear is walking up above the earth, and it's not at midnight, right? Look at this, it's a different time of the day. So, no, the stars are not in the same spot all year round. The stars move around in a great circle during the day, and they also do a separate circle over the course of a year. And when you add those two circles together, you will see that the stars are in a different place at different times of the year. The only one that doesn't move, of course, would be the North Star, the Polaris. Up here in the Northern Hemisphere, Polaris does not move. And that's why we use it as a guide star. It's always there. Let's look at a few more. There's still a contingent out there of people who insist, no, the stars, this isn't right. That's just Stellarium. It's just a simulation. It's not real. That, my friends, is the Big Dipper, right? That is the Big Dipper. So if you don't believe Stellarium, you think that the Big Dipper doesn't do what I just showed you, what I want you to do is go out at night and check. Just go out tonight and check, where is the Big Dipper tonight? Let's set it to tonight. Okay, go out and find it. Go out at whatever time you want and find the Big Dipper and tell me Stellarium is right or wrong. And then wait a month, wait 1 month, and come out again in December at the same time and tell me, has it moved? 1 month later, has it moved again? Has it moved again? Has it moved again? Yes, it will. It will be going around in a great big circle, just like that. Okay. So yeah, if you don't think that's the case, by all means, go out and try that out. A couple other things just to float out there for anyone who is still saying, no, the stars are the same every single night. Let me just remind you of a little thing called the Zodiac, the Greek Zodiac. You know, astrology, this whole like, oh, you're in Aquarius, ooh, that means, right? That, of course, is silliness. But what is the Zodiac? What is the Zodiac? Can we see that in here? Zodiac. Can we see the whole Zodiac? No. Let's see Aquarius then. Aquarius. Let's see Aquarius. There's Aquarius. There's a constellation. Why are these particular constellations associated with months of the year? Why is that? Well, let me tell you, it's because the ancient Greeks even knew that the stars are in different places throughout the year. Aquarius goes below the horizon. Here it is in February. It's going to be below the horizon at night. And we have to wait until, you know, down here in October, Aquarius will be up in the sky. Right? Aquarius is up in the sky at night, and then it goes down below. Right? That's because the zodiac constellations are down near the equator, the celestial equator. So as we go around 6 months later, those are the stars that we do not see at night. We only see them at certain times of the year. And so what are the other ones? Taurus. There's Taurus. And we're going to see the exact same thing here, that depending on what time of the year it is, it's going to be in a different place. North and south, up and down, it's going to be a different place, rising and setting during the day as you go throughout the year. And those constellations are associated with a time of the year because that's what they do. Because they rise and they set at different times of the year. It's baked into the astrology, it's baked into the zodiac. So absolutely, it has been known for millennia. And it's really just kind of ironic that in our modern age, we don't go out and stare at the stars like the ancient people did. We stay in and we watch YouTube, right? So we stay in and we watch YouTube, and because of that, we don't know these things. We don't realize that's why the zodiac exists, because the ancient Greeks used to look at the stars and they would say, oh, hey, look at that. There's Taurus. I see Taurus, you know, this time of the year. And so when Taurus rises, and you were born when Taurus was rising out of the sky. And so that means something about you, right? Oh, and hey, there's our friend Orion. I was just mentioning Orion. Boop. There's Orion. A lot of us know about Orion. It's a well-known constellation, but you're not going to see it all year round. And the reason for it is because its declination, the declination of Orion is only 5 degrees. It's only 5 degrees up off of the equator. So only when your night sky is tilted down towards Orion will you be able to see it at night. When your night sky is tilted away from Orion, you won't be able to see it at night. And there you go. And so those stars that you do see every night, such as the Big Dipper, aka Ursa Major. Oh, come on. Show it to me as, won't show it to me. They're too proper on this one, I guess. Ursa Major. That one stays above the horizon because its declination 55 degrees. So we vary on our tilt as we go around. The Earth is tilted 23.5 degrees. So we're either tilted, in this shot we're tilted away from Ursa Major by 23 degrees. And then later in the year we'll be tilted towards Ursa Major. There you go. We'll be tilted towards, there you go. Tilted towards Ursa Major by 23.5 degrees. So as the Earth, the Earth goes around the Sun, that tilt will stay, but either it's tilted towards the sun side and away from the night side, or it's tilted away from the sun side and towards the night side. If it's tilted towards the night side, you see farther down towards the equator, and you can actually see, depending on how far north or south you are, you might see stars, you know, in the southern, you see some southern stars that are even past the equator, right? Okay, hopefully that helps and that explains it. Let me know if you want to follow up on this, particular Onda Galapago. Thank you for the question. And let me know if that helped, if that explained it thoroughly enough. It is pretty hard to picture, but let me say Stellarium is your go-to on this. All right, have a good one.